Good afternoon. Today I'm going to give you a video presentation of my progress report in the development of biochar activated carbon from bamboo as an absorbent using a self-sustained carbonization with a controlled chemical activation for the ammoniacal nitrogen removal. My name is Sharifah Nazira, and my main supervisor is Professor Nader Dr. Jufri Idris, and my co-supervisor is Dr. Technologist Siti Kartina Abdul Karim. Both of them are lecturers from UiTM Samarahan. Okay, as we want to introduce the background, we want to use this biochar activated carbon for absorption of the ammonium nitrogen in agricultural activities, because we can have this ammonium nitrogen inside the water through leaching, runoff, and precipitation, and this can cause a lot of problem for the marine ecosystem. And here, the conventional methods is where the biochar or biochar activated carbon is used in the coagulation process, where it can absorb all of the ammonium nitrogen. And here we can see that in previous studies that we have used coal, coconut shell, wood, sugarcane, bagasse, soybean, hulls, and the nutshell for this absorption. So we want to prepare this activated carbon by pyrolysis, and here we want to activate it for efficiency to absorb ammonium nitrogen. Here are a few of activated conventional activated carbon. We have physical, chemical, physiochemical activation, and microwave assisted activated carbon. So here, activated carbon, the downside is that it has a cost-intensive regeneration process. So we want to lower the cost to make this activated carbon. Okay. And here is my proposed flow, where first one is where we cut the raw bamboo and undergo self-sustained carbonization, and then we undergo controlled chemical activation, and then we use it for absorption of ammonium nitrogen, and then we use it for the real agricultural waste, okay, wastewater. Okay, my major milestone. Okay. Here, I think the problem statement is that you want to see the effectiveness of this bamboo and study the performance on the optimized bamboo activated carbon, and study the characterization of this bamboo activated carbon. And my research objective, the first one is to evaluate and characterize raw bamboo and the biochar produced using self-sustain in terms of ultimate, proximate, and surface morphology. Then to evaluate the activated carbon characteristic from chemical activation at different temperature and retention time using acid impregnation. And then to study the kinetic modeling of one-way Finlay's absorption using activated carbon for ammonium nitrogen removal in single synthetic ammonium nitrate solution for different temperature, master stage, and initial concentration. And then to evaluate the performance of this optimized activated carbon for treatment of plantation agriculture wastewater in terms of the pH, COD, BOD, and the turbidity of the effectiveness. And in this scope, we want to see that the real application, kinetic modeling, the jar test, and that one is from the application. But for the production, we want to see about the activated carbon as absorbent. We want to see the characterization from self-sustain and from chemical activation. And here, okay, bamboo biochar have a large surface area, high porosity, many functional group, and high cation exchange capability, and it's also stable. Okay. So it have a very good quality compared to other activated carbon. So here we want to reduce the time, energy, and cost of to produce quality activated carbon by using appropriate carbonization technology, which is self-sustained, which is the novelty of this research. So here we want to start in my research methodology, where we start at the preparation of bamboo feedstock, and we undergo self-sustained carbonization. And then we undergo controlled carbonization and chemical activation. And when we have select the best bamboo biochar activated carbon, we will go for the selection of the uh, best quality and kinetic modeling. And then lastly, the evaluation of optimized activated carbon. Here is the objective number 1, where we do the characteristics such as proximate, ultimate, surface morphology, and functional group for this bamboo biochar that have been put in the self-sustained. This is the self-sustained. This is a self-sustained um, vector. And this is my second objective. So second objective is for me to choose the best one for the best activated carbon from objective number 1, and to optimize it. Okay, and we select it by BET analysis, surface area for volume. And for chemical activation, we use the phosphoric acid 5:1 ratio, and then we carbonize it using this split tube quartz pyrolyzer, okay, using nitrogen gas. Here is our parameters. We do proximate, ultimate, surface morphology, and functional group. And the objective number 3 is for us to produce CE and QE for kinetic long-way isotherm modeling from the jar test. Here is the 3 where we use OFAT, okay, where we select the optimum temperature, mass dosage, and initial concentration. Okay, this is the analysis where we see the kinetics to produce the isotherm model. So this is the last part where we check the effectiveness through the pH, COD, BOD, turbidity, and ammonium nitrogen at the real life experiment. So experiment, what I meant was taken from the wastewater from agricultural farm in Samarkand. So you see here we will analyze pH, COD, BOD, turbidity, and ammonium nitrogen. So in my data collection, I think most the self-sustain here. Sorry, I did not change this. I think these 3 have been determined, but there are some result that is invalid, so we need to do it again. Okay, this is the absorption test, the efficiency test, and this is the result that I've got for ultimate analysis for Bambusa and Esper. And this is the proximate analysis for Bambusa, and this is for Esper for the 2 species. And this is the FTIR, where it shows the functional group on the surface area of this bamboo biochar, the raw and the activated one. Here is the SEM images where we have micropore at 824 nanometer. Okay. So here, so we have a few types of pore here. Micropore less than 2 nanometer. And this is my surface area, the BET analysis where we have done for the raw, for the subsustain of the Denver Calamus esper, and surface modification. Okay, we did the surface modification first because of we don't want to do any activation at first of my study, but now the surface modification gives us a low BT, low power volume, and low pore size, so we have to go for activated one. And I've tried the using phosphoric acid and using potassium hydroxide. So we will using phosphoric acid um, as an activation, not by surface modification. Here is my result where the lower is I think there's some kind of error, so we need to do it again. Here is most of the things that I've done. Okay, and now I think yeah, I think supposedly I have done the absorption, but it's nowhere near this because I think in my last progress report I said that I will go to Shah Alam in August, but then the machine, uh, the pyrolyzer has been broken. The glass quartz has been the quartz has broken due to some experiments. So um, we need to improvise, and me and my supervisor gather up the grant to buy uh, a split tube pyrolyzer to be put in UITM Samarahan 1 okay, at the FKK there. Okay, status for publication. I'm doing the review of production, activated and application of the reactivated carbon, where I'm still editing it for publication as a review. And status of conference. Okay, last September, I did went to the first international conference on biotechnology, smart farming, and entrepreneurship for food security, where I did a poster presentation of Dendra calamus ester activated carbon for ammonical nitrogen removal, where we do a poster presentation. Okay, and I did not win any award, but this one is as a condition for my PhD. So I think I will be attending more international conference. This is writing because I'm still waiting for compiling the result, and for journal publication, discussion, and comparison for the literature. I've not started my thesis. Okay. Okay. For the next semester, okay, the furnace, the pyrolyzer split tube furnace pyrolyzer have been purchased, and it have arrived here in UiTM Samarahan 1, and I will resume my experiment by February till July for the carbonization, and the absorption experiment will be done here in UiTM Samarahan 1, and I estimate that I will finish this by this year. Thank you.